Hi, in this video we will learn about basics of indeterminate form 0 over 0. So where this indeterminate form comes in, well, everything's go back to the quotient law. What does quotient law says? Says that, okay, if you're trying to find limit of quotient, and if the limit of numerator and denominator exists, you can check first something, that if limit of the denominator is a number, non-zero number, then we can apply the quotient law, and it says that, okay, you just limit of quotient is quotient of limits. So you can find limit of numerator, limit of denominator, and then divide them. Well, what if the limit of the denominator is 0? Well, if the limit of the denominator is 0, unlike the other case which was solved by quotient law, now we cannot use quotient law, because quotient law works only for the cases that the denominator has non-zero limit. Well, if the limit of the denominator is 0, so we have to figure out something new, something to which helps us to find the final limit. Well, there are two cases. Case 1, where not only the limit of denominator is 0, the limit of the numerator is also 0. In this case, we will have indeterminate form 0 over 0. Well, what this says is that you are in a special case and you have to find a way to deal with this. Find a way to resolve this issue. Because 0 over 0 is not a number. I cannot say if the limit exists. I cannot say if the limit does not exist. So you have to find a way to deal with this case. Just to have a complete chart, there is another case in which the limit of the numerator is not 0. When the limit of the denominator is 0 and limit of the numerator non-zero, in that case you can conclude that f of x over gx, as x goes to a, the limit does not exist. Actually, this in detail we will discuss it in another video. This is an infinite limit and it has its own work that we will do in another video. But in this video, we will just work on this piece. When the limit of the numerator is 0, when the limit of the denominator is also 0. What shall we do in this case? So what to do? What to do in this case? Limit of numerator is 0, limit of the denominator is 0. So there is a very nice and easy fact here to understand, especially in our cases that we are working with rational functions, polynomial over polynomial. When limit of an expression, an algebraic expression, is 0 as x approaches a, it means that the expression has a factor x minus a. It means that the expression has a factor x minus a. That's why when you let x go to a, this piece will make it 0. We call this factor vanishing factor. So we have a vanishing factor. Now both numerator and denominator have these vanishing factors, because that's why we get 0 in numerator, 0 in the denominator. So that's the reason. Now what shall we do here? Well, we need to decompose both numerator and denominator, decompose them and find the vanishing factors. When you have the vanishing factors, both in numerator and the denominator, you can cancel them, and then you will have non-zero limit either in numerator or in the denominator. So this, let me continue. Find the vanishing factors and cancel them before finding the limit or evaluating the limit. So first, if you have 0 over 0 form, it means that you have x minus a factor in the numerator, x minus a factor in the denominator. You have to find them, you have to cancel them, and then find the limit. Okay, let's see in some examples. Example, evaluate the limits. Well, I'll go one by one. First one is limit of x going to 1 of x squared minus 2x plus 1 over x squared minus 3x plus 2. Well, separately you find the limit of numerator. So here, limit of numerator, which is limit of a polynomial, and we know that for polynomial it's just same thing as just substitution, direct substitution. 1 squared minus 2 times 1 plus 1, which makes it 0. The limit of numerator is 0. Limit of the denominator is 1 squared minus 3 times 1 plus 2, which is again 0. Both of them are 0, so as a result, we are at 0 over 0 indeterminate form. Well, this means that both of our numerators and denominator, they have the factor x minus, here in this case x minus 1. So we need to factor both numerator and the denominator here. In the numerator, actually we have 2 of those factors. In the denominator, we have x minus 1 and x, you see sum of them is negative 3, and their product is plus 2, so that means that we have these 2. as x goes to 1. Now you see this can cancel with that one, and we get limit of x minus 2, x minus 1 over x minus 2 as x goes to 1. Now we are finding limit of a different function, which will give us the same limit as the original function, but this is a different function. Now you have to ask yourself, can I use the quotient law here? Well, to do that, we need to check if the limit of the denominator as x goes to 1 is 0 or not. Here, well, actually no, it is not. It is -1. That means that we can use quotient law, and we will get limit of x minus 1 as x goes to 1, and limit of x minus 2 as x goes to 1, and plug in there 1 minus 1, 1 minus 2, because these are polynomials. Now 0 over -1, which gives us 0. That's it. The limit of this function, which originally turned out to be an indeterminate form, is 0. Let's do another example. Example 2. This is limit of x squared minus 2x over x cubed plus 3x squared plus x. So you have quotient. First thing is quotient law. Check if the limit of the denominator is 0 as x goes to 0. This is 0 cubed plus 3, 0 squared plus 0, which gives us 0. Well, that means that we cannot do the quotient law, but we need to check the limit of the numerator. The limit of the numerator, it's again another polynomial, and we can get by direct substitution. It will give us another 0. Okay, that means that we are having a 0 over 0 indeterminate form, and here the vanishing factor is x minus a, which is x minus 0, and that's just x. So we have to find the factors of x in both numerator and denominator. In this case, it's easy. Just factor out x's. Yes, x minus 2 in the numerator, and then we get x squared plus 3x plus 1 as x goes to 0. Now we can cancel these two, and we get another limit of x minus 2 over x squared plus 3x plus 1. Now this is again another quotient function. We have to do what? We have to check if the limit of the denominator is 0 or not. If it is non-zero, we can use the quotient law, and that would make our life much easier than the other cases. Okay, yes, it is 1, which is non-zero, so we can apply the quotient law, which says that we'll find the limit of the numerator. Sorry, let me write this a little bit better. Okay, limit of the quotient is equal to quotient of the limits x squared plus 3x plus 1. And this gives us 0 minus 2. These are polynomials, so you just plug in. Then 0 squared plus 3 times 0 plus 1, which is negative 2 over 1, and that is negative 2. Well, that's how we find. Let me just do one more example in which the finding the vanishing factor will be a little bit different. X squared plus 4 minus 2 over x squared as x goes to 0 again. Well, here again we have quotient. This time the numerator is not a polynomial, but it's a good function still. We start checking the limit of the denominator as x goes to 0. This is 0 squared, which is 0. Since the limit of the denominator is 0, that means we cannot use quotient law at this stage. And to be able to proceed, we have to check the limit of the numerator also. And while using the different laws, the quotient, the root law, and the substitution property, we have 0 plus 4 minus 2. This is 2 minus 2, which is 0. So as you can see, we are in 0 over 0 form. 0 over 0 is not limit value. You cannot put 0 over 0 as the value of limit. You have to do something and get rid of that 0 over 0 form. Well, okay, in this case, you see that the vanishing factor, again, this is x minus 0, which is x. We have to factor out x in some way, some ways. But you notice that the numerator is not a polynomial. Factoring non-polynomial functions are not easy. And, well, you need a trick. And trick here is that you multiply both numerators and numerator and denominator by the conjugate of the numerator in this case. Well, what is conjugate here? If you have square root minus something, the conjugate would be the same square root plus that something. And we are multiplying, we are dividing, so we are not changing anything in this case. And this gives us what? So a minus b times a plus b. This will give us, that's the whole point of conjugate. The first one is squared minus second one squared. In the denominator, well, let's just write this one without any expansion or anything. Just leave it like that. And x goes to 0. What happens in the numerator is that, well, limit of x going to 0 will give us x squared plus 4 minus 4. This cancels with that. And this way, by multiplying the numerator and the denominator by the conjugate of the numerator, you see that we ended up with something very nice. X squared over x squared root x2 plus 4 plus 2. Now x goes to 0. Well, the vanishing factor is now time to cancel them. We get rid of those vanishing factors, and then we have root x4 plus x squared plus 4 plus 2 as x goes to 0. Well, you can check everything here first before you go and complete this step, but quotient law can be applied because the limit of the denominator is going to be non-zero. So I just went straight to that law, and here I have 1 over 0 squared plus 4 plus 2 which if you do all the computation, you get 1 over 2 plus 2 is 1 over 4. So the original limit first ended up with 0 over 0. We did all this work to factor out the vanishing factors, then cancel them, find the limit. The final result is 1 over 4. So that is one case of the case 1 of when the limit of the denominator is 0. The quotient law fails. Now you have 0 over 0, and then find the vanishing factor from the numerator, denominator, cancel them, and then find the limit.